The children, this numerical is from work per energy. So especially this numerical we are going to solve by using law of conservation of momentum and a law of conservation of energy. Okay children, fine. So first let us see the question here. So it is given that a block of mass m, a wooden block, is suspended by means of a string. Children, here OA is a mean position. Okay. Now what happened is that a bullet of bullet of mass m move with the velocity v, okay, it strikes. So that bullet is embedded in the block. Then what happens? The block along with the bullet is raised to a height h. Raised to a height h, such a way that the string is making an angle theta with the initial position. Now we are asked to calculate the angle theta. So children, step by step let us solve that, so that's very easy to get, don't get confused at all. Okay, now fine. So first children, let us apply the concept of conservation of linear momentum children. So according to the conservation of linear momentum, initial momentum must be equal to final momentum. So initial momentum must be equal to final momentum. First we should know what is a momentum children. So momentum is a mass into velocity. So initially it's a system children, and here is a final system. So initial system. So for a bullet, what is the momentum children? Mass into velocity. Then what is the momentum of the block? Capital M. So as initial at rest, it is a 0 only. Right? This is the initial momentum. Then what will be the final momentum children? So entire block M, that is a block with the bullet, is going with the velocity capital V. So here once the bullet is embedded in the block children, we should consider block and bullet as a single system. Okay, fine. So according to that, mass into, that is the mass means we have to include bullet mass and block mass into velocity v. So it will be mv is equal to m plus capital M into v. So from this children we can write v is equal to mv by m plus capital M. So children, let us say it is equation 1. So this is a now velocity of the bullet and block children, bullet and a block. So with this velocity, just it is moving so that it is raised to a height h. So now one part is finished. Here we applied the conservation of momentum. Now let us apply the conservation of energy. So let us, this is position A, point A, and let us see the position B. So as per the conservation of energy children, so let us assume that there is no energy loss. Obviously, the energy at a point A must be equal to energy at a point B. Okay, fine. So as per the conservation of energy children, energy at a point A must be equal to energy at a point B. Children, energy at a point A, its almost height is negligible. So whatever the body here it has energy, it is in the form of kinetic energy only. And here as it is raised to a maximum height, at a maximum height, velocity will be 0, so no kinetic energy. Here body has only potential energy. So which means what children? So kinetic energy at a point A must be equal to potential energy at a point B. So here kinetic energy form is what children? Half mv square. M is a mass. Mass means what here? At this position already here bullet is entered into this, right? Okay now. So mass means m plus capital M we should take, and its velocity is v square. So at this point it has only potential energy. The formula is what? mgh. M means what? M plus capital M, it is a gh. So this here we operate just conservation of energy only. We operate the conservation of energy. But here how to calculate the v children? So just recall the concept of simple pendulum. For suppose here is a simple pendulum of mass m. When it is given a velocity v, so that it is raised to a height h children, then v square is equal to 2gh we have. Let it be the equation 2 children. Now get this here. So v square is equal to 2gh, right? Yes. So v square is equal to 2gh. But here h is not known, right? H is what? The height to which the block is raised. So children, here we can calculate. How we can calculate? For suppose children, as per the question, if you can see this angle theta. Okay, now so let us say this is the height to which it is raised, and this total length is L. Okay, so this is O. Let us say this is a point A, this is a point B. Now as we need children here, OA we need. So let us define the cos theta, right? So here cos theta is equal to adjacent side by hypotenuse, that is the OB. So children, OB is nothing but what actually? It's the length L only, right? So obviously OA is equal to OB length L into cos theta. So this OA is what actually? L cos theta, children. This is what actually? L cos theta. L cos theta. Children, this total length is equal to, it can be written as OA plus, let us say this height is h, right? So from the picture, children, from that figure, we can write that here L is equal to L cos theta plus h. So from this, h is equal to, you can take L cos theta left side, so that you can take L as a common, 1 minus cos theta. Let it be equation 3. Okay children, fine. Now this h value you can substitute here, and the v value from first equation you can substitute here. Okay na? So let us say this is equation 3 actually. So this you can make as a 4. So children, substitute what we can say 1 and 4 in a 3 children. So in the place of v square, if you write this one, so what will happen? It is going to be m square v square by m plus m whole square, which is equal to 2g. In the place of h, we are going to write, that is L into 1 minus cos theta. As we need cos theta, we want actually get this 2gl left side. Okay, so then it will be 1 minus cos theta is equal to m square v square by m plus m whole square. So as we need a cos theta, so cos theta you can take a left side, entire term you can take a right side. Okay, that is the left side, you can take a right side. So it can be written as cos theta is equal to 1 minus m square v square by m plus m whole square. So from this, theta is equal to, children, are you able to see? Let me check. It's really going to this one. Oh, you are not able to see. Okay, fine. So let me take this place here. I think it is seen here. So as cos theta is equal to this one, children. So theta is equal to, here it is again cos inverse. It is cos inverse 1 minus m square v square by m plus m, it is whole square, m plus m whole square. Is it clear? So this is a angle made actually. Here we get one doubt. Sir, then what is the purpose of equation 2? So in some other type of numericals, they will ask you to calculate the height to which it is raised. So in that case, you can use equation 2 to calculate the height, children. Okay, thank you.